Alright, so in the previous video we talked about the gradient of a line, and there was a particular reason that we were actually discussing that, because what we want to do is construct the graphs of the linear equation. So a linear equation, let's revisit our the concept of linear equations. What is a linear equation? We actually have a video on that, so you can just go and revisit that. For example, a linear video could look something like y is equal to 2x plus 3. This is a linear equation because if you construct a table of the values for x and y and consider it as a function, and then input the values, random values for x, you will get some values of y that will be dependent upon the values of x that you input, and then you get some coordinates and points, and then you plot them coordinates and points on a grid, and you connect them together and you get a line. And I hope that you can just go and revisit the video if it is not making sense to you. But this is how you can construct the graphs of linear equations. But since now that we discuss the gradient of a line, it will be useful for us to understand that how we can incorporate that concept into this a graphical representation of linear equations. So for that, we would first of all have to draw uh, you know some axes here. So I can draw some axes. So this is the y-axis, this is the x-axis. By convention, you can always use this convention in order to draw your graph. So y is always vertical and x is always horizontal. And then you can just put some scaling on it: 1, 2, 3, 4, 5, 6, and 7. And let's say 1, 2, 3, 4, 5, 6, and so on. And this is the 0 origin point: 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, and so on. Right. So here, if if we just revisit that that practice of plotting the graphs of linear equations, what we actually need to do is we need to first of all make a table for values of y and x, and then it can go something like this. For the values of for example, you can just put x to be equal to 0 and see what is the value for y. The value for y is going to be 3. If you put x to be equal to like 2, the value for y is going to be 2 times 2 is 4 plus 3, 7. If you put x to be equal to, let's say, 6, the value of y is going to be equal to 15. Which it's not saying to make that because we don't have 15 value here. But yeah, you can just plot at least 2 points and be able to draw a line. For example, when x is equal to 0, y is equal to 3, so the point actually is here. And when x is equal to 2, y is equal to 7, so something somewhere over here. So you can just connect these 2 points together. Okay, that's not the most accurate connection of points. Okay, that's a little bit better. So this line actually represents this equation: y is equal to 2x plus 3. You can either write it down like that, or just take a grid and scale it down, and then just draw a line that would actually be representing this equation. We have talked about this in a previous video, so I won't actually be putting much focus on that. So we just drew these 2 points, and we were able to construct this line. But my claim is that without even having a need to draw this table thing, and just trying to put some arbitrary values for x and then getting some output values for y and be able to draw a line like that, we could already draw a line. We could already sketch a graph by just looking at this equation. So for that, we need to generalize something here. If we, for example, if we just what we do is that if we construct a triangle between these two lines, like the one that we did in the previous video, you can see this is a line with certain inclination, and we know that when there is an inclination, there is a gradient or slope. And well, how do we calculate that? The formula we studied was the ratio of rise to the run in something. Not rum, it's a run, right? So in this case, the rise is the change in the values of y here. So this is the rise. And the rise, as we can see, this is 7 minus 3, which is 4. So the rise is of 4 units, and the run is of from 1 to 2, 0 to 2 it goes. So of 2 units, right? So rise over run will give us the value of 4 over 2, which is equal to 2. So the gradient of this line is equal to 2, right? And if we, for example, put x to be equal to 0 like we did here in this case, we got the value for y is equal to 3. So we can see that our graph or line intersects the y-axis at 3, right? So this point, this whatever the value we add after this, 2x thing, will always give you the point at which the graph will intersect the y-axis, because all this thing here is multiplied with x, right? So if you put x to be equal to 0, then this whole thing gets cancelled out, and you're only left with this, which will actually be the value for y when x is equal to 3. So we can generalize this equation, right? So we can write it this: y is equal to mx plus c. Here you can see that it's 2x, and we got to know that the gradient of this line was 2, and we can compare these two equations together, and we come to know that, okay, whatever there is in this general form of the equation, whatever there is multiplied with x, that is actually the gradient of the line. If it is 2x, the line is going to look like something like this. If it is only x plus 3, then the gradient of the line will actually be not 2 but 1, and it will have a little bit less gradient. The line might look something like this, or I'm not even sure. We need to draw that and see, but I'm sure it will be less flat than that. If there is no gradient at all, if it's only y is equal to 3, then the line will actually look flat at y is equal to 3, right? So this is a line y is equal to 0x plus 3. There is no gradient. So only y is equal to 3 would look something like this. And this is the general, equation of a line. Y is equal to mx plus 3, where m is the gradient and c is the point that intercepts the y-axis, right? So uh, interception at y-axis. So this is a very useful equation that we'll be using in our mathematics to solve problems. We don't have to construct a table all the time. We could always be just looking at an equation and figuring out how the sketch of our graph will look like.